Well, hello, welcome to the beginning, really, of our Chapter 1 in our beginning Algebra Math 60 course. This is a PowerPoint, and there'll be a number of them for each section, a PowerPoint with some video and some questions and annotations and things to help you learn, really. And I'm going to go through them rather quickly because sometimes you don't need to sit in front of a long video, but you can always pause to work out some of the problems that I present, and or you can review, rewind it and go back over something. So I'll move fairly quickly through it. So this is PowerPoint number 1. It's just an intro to algebra, introducing some of the language that we're going to be doing. And it does correspond with section 1.1 of our book. So begin, we just did a review of a lot of arithmetic with fractions, decimals, and such. So on fractions, let's just review some quick things. When we say we want to simplify fractions, that means putting it into its lowest terms. A fraction is in its simplest terms when the numerator and denominator have no common factors. Now remember, factors are things being multiplied. So if there's something in the top and the bottom that's being multiplied the same, we can reduce those, and this will refresh your memory. So for example, if we had 18 over 45, we can see both numerator and denominator. The 18 can be seen as 9 times 2. The 45 can be seen as 9 times 5. So we say common factors. You can see there's a multiplying by 9 here and a multiplying by 9 here, and so those would be considered common factors. So then we can say, well, 9 over 9 is just 1. 1 times anything is itself, so we end up with just this value of 2/5. So common factors means we just reduce fractions by taking out common factors. So no common factors left with 2/5. Now, also with reviewing and fractions, we're going to look at multiplying fractions. Multiplying fractions is actually the easiest of all fractions operations because we multiply the numerators, then we multiply the denominators. That just means we multiply top times top, bottom times bottom. For example, if we had 3/4 times 5/6, it literally means multiply the two numbers on top, 3 times the 5, and multiply the two numbers on the bottom, 4 times 6. And when we do that, we get 15 over 24. But again, every time we have a fraction for an answer, we want to make sure it's reduced, which means we want no common factors. So we take that fraction of 15 over 24, we look at it carefully and look at all of its factors. 15 is 3 times 5. 24 is 3 times 8, which clearly means there's a common factor of 3 in both top and bottom. We reduce that by seeing that that is 1, and we get a final answer of 5/8. So multiplying is actually rather easy. Top times top, bottom times bottom, and then make sure we reduce. Now when we divide fractions, it's just like multiplying with one additional step. When you're dividing fractions, the very first thing we do is not actually divide. We invert the second fraction and then multiply. Now invert means flipping over, and when we do that, for example, when we have 3/4 divided by 5/6, the very first thing we do is we take the second fraction, the one that's dividing into, and we invert it or flip it over. So this becomes 3/4 times 6/5. We just literally flip it over, and once it's multiplication, like we just reviewed, we know how to do that. Top times top, bottom times bottom, we get 18 over 20. Then we look to simplify, and 18 is 2 times 9, 20 is 2 times 10, so clearly they have a common factor of 2. We reduce that, and when we do, we get an answer of 9/10. So there's a little review of multiplying and dividing fractions. Next, we're going to add fractions. This is the one that really adding and subtracting tend to give students the most challenge. Adding fractions, we need to find the LCD, which is the least common denominator. In other words, we need to rewrite the fractions with this common denominator and then add the numerators. So that's usually the challenge for most students when you add and subtract, not in multiplication, not in division, only addition, subtraction. We do have to make sure that the denominators, the bottom parts of the fractions, are both the same. So for example, if we had 3/4 plus 5/6, we need to look at these denominators and say, what's a number that both 4 and 6 can go into, so we can convert these fractions to have that common denominator. So what we've decided is that 4 and 6 both go into the number 12. And so how would we turn a denominator 4 into 12? We would multiply by 3. If we multiply the bottom by 3, we must also multiply the top by 3. that way we maintain a fraction that is equivalent to 3/4. The same is true, how do I get the 6 into a denominator of 12? I'd need to multiply by 2, and if I multiply the bottom by 2 to make it 12, I also have to make sure I multiply the top by 2 as well. And so when we do that, we get 3 times 3 is 9, 9/12. 2 times 5 is 10, 10/12. Now that you can see we have common denominators, which we must have for addition and subtraction, we're essentially saying I have 9/12 plus 10/12. I have 9 of these guys, and I'm going to add it to 10 of these guys, same guys. So 9 plus 10 gives us 19/12, which is our final answer. Now, if we want to, we can see, well, look, the numerator is bigger than the denominator. This is called an improper fraction. You cannot reduce it. There are no common factors, but you can rewrite it. And many of you know how to do that by turning it into what's called a mixed number. A mixed number just simply says if the numerator is larger than the denominator, how many times will the denominator 12 go into 19? In this case, 1 time. So 12 goes into 19 once. And when you take 12 away from 19, that leaves 7. So 1 and 7/12. Our last review then will be subtraction. Subtraction is going to be exactly like addition. You need to find the common denominator, then convert each fraction, rewrite each fraction with that common denominator. The difference here, now when you get to the end, you just subtract the numerators. You don't add them. And so if we had 3/4 minus 5/6, we still build our common denominator of 12 by multiplying top and bottom by 3 to get 12. Multiplying top and bottom by 2 to get 12. We have to have common denominators. But once we have that, now we're just subtracting the numerators. 9 minus 10 equals -1. So -1/12, or -1/12. The other thing we want to review here early on is order of operations. We called it the order of operations, our addition, subtraction, multiplication, division, and the very common, easy to remember acronym is Please Excuse My Dear Aunt Sally. Please Excuse My Dear Aunt Sally means PEMDAS. Some of you have heard it referred to as PEMDAS. Here's a problem we'll work on as we talk through our Please Excuse My Dear Aunt Sally. And it's 10 minus 3 times the quantity, 4 minus 9 quantity squared. So in the PEMDAS, the P stands for parentheses. Always do what's in the parentheses first. And so we're going to do what's inside the parentheses first, which is 4 minus 9. And when we do 4 minus 9, that gives us -5. The E in PEMDAS, or for excuse, is exponents. After we've done everything in the parentheses, we always make sure we carry out the exponents, because we really don't know what 3 is being multiplied by here until we figure out what this is. This is -5 squared, so we have to do that exponent first to determine that. So -5 squared literally means -5 times -5, which is +25. So now we've done the exponents. Next comes the my dear, which is multiplication and division. In this particular problem, 10 minus 3 times 25 only has one multiplication problem, no division problems, so we would want to do that next, which gives us 75. So we're left with 10 minus 75. The Aunt Sally is the addition and subtraction part of our PEMDAS. Addition and subtraction gets our last priority, which means we do it very last, unless of course it's inside parentheses, but we carry this out equally. So 10 minus 75 is -65. Order of operations, PEMDAS, please excuse my dear Aunt Sally. And then now that we're heading into algebra, we want to review some of the terminology that's used. A variable. A variable is simply a letter that represents an unknown number is called a variable. If we have a value like 5, we use those all the time. They're perfectly good. But if we aren't sure, if we want to leave something open, then we often use a letter. Typically, we end up using the letter X, but of course you can use any letter that you'd like. But anytime we use a letter that's really a placeholder, holding the place of some value or number, we call that a variable. An algebraic expression is a meaningful collection of numbers, so we still use 5s and 7s and 1/2, of variables, letters, X, A, T, and operations. Operations, add, subtract, multiply, divide, parentheses, exponents. So expression is just a combination, a meaningful combination of those things. Operations in algebra, we want to identify the operation I indicated. So a lot of times mathematics will be presented to us not always in expression or equation form, but presented to us in verbal form, either spoken or written. So we have to read and be able to interpret what's being said. So when we see phrases like decreased by, what does that mean? You know, divided by. These are all terms that we're going to see. Difference, multiplication, addition, from, plus, product, divided into, more than, times, quotient, subtract, take away, division, of, increased by, per. See, these are all terms that are going to be used, and I know it's overwhelming. I'm throwing them all at you, but as we sort through them, you'll see how they come apart. Minus, sum, less than. These are a lot of different terminologies. Ratio, triple. So there's a lot of terms that can be written in sentence form or expressed verbally, and each of them represents a certain operation: add, subtract, multiply, divide. So for example, for addition, we might say addition, more than, increased by, plus, sum. Those all could mean addition. Subtraction, we could use the terms minus, take away, from, subtract, difference, less than, decreased by. Now, in terms of pure algebra, some terms you're going to see used a lot. For addition, we often use or refer to sum. The sum will always mean addition. Difference is the key algebraic term that is often used that means subtraction. In multiplication, we might just say multiplication, but we could also say times, or of, or product, or triple, or double. There's lots of ways to say it, but for multiplication, the algebraic term that's most often used is product, the product of 2 and 3, as opposed to the sum of 2 or 3, as opposed to the difference of 2 and 3. And then lastly, the division. We could just call it division, but we also will see divided into, divided by, quotient, per, or ratio. All of these are going to imply division. Don't worry, you won't be confused. Only one of them at a time will ever be used. And in terms of algebra, the term that is most formal and most commonly used would be quotient. So when you hear the sum, difference, product, and quotient, you're talking about addition, subtraction, multiplication, and division. So let's go through a few and let you practice. Translate the following phrases into algebraic expressions. Here's our phrase: 5 less than twice a number n. How would we write that using the proper math symbols here, using algebra with variables, operations, numbers? 5 less than twice the number n. So look at the options and see which one you think it is. The correct answer is 3. 5 less than, here you go, minus 5, 5 less than, twice a number n. So our variable is n, so twice a number n means 2 times that size. So it's 5 less than twice a variable n. Very good. Let's practice another one. If x is an integer, what is the next consecutive integer? Consecutive meaning the one that immediately follows. If this is the integer we're starting with, x, how would we write the next consecutive integer? The correct answer is 2, x plus 1. So if we had an integer x, let's just say we had 6, what's the next consecutive integer? Well, after 6 would come 7. So if we knew x was our first integer, 6, how would we then go to the next consecutive? Well, the next one would be 1 larger. So that's why we would write it as x plus 1. 2 more to practice before we wrap up. If x is an even integer, 2, 4, 6, 8, 10, if it's an even integer, what's the next even consecutive integer? So we're going from even to even. So which of the statements, expressions below do you think would best represent the next even consecutive integer, assuming x is the even number we start with? The correct choice is 3, x plus 2, because again, if we started with x being an even number 6, the next consecutive integer is 7, but we want the next even consecutive integer, which would be 8. So we wouldn't add 1, we would actually need to add 2 to get to here. So this would be x plus 2 is our next even consecutive. Now the tricky part of this is, what if you started with an odd number like 7? How would you get to the next consecutive odd integer, which is 9? You would still, if this was your x, you would still add 2 to get to the next odd integer. So whether you're going from even to even or odd to odd, it's still going to be the x plus 2. And then lastly, let's wrap up with this one. Let's look at a more application type problem. John had $150 before spending P dollars on pizza. So we don't know how much he spent on pizza, so we're just letting a variable represent that amount, P. But if he had 150, then he spent P dollars on pizza, how much money remains? Now, which expression represents this problem the best? The correct answer is choice 4, 150 minus P. Because if he started with 150 and he spent P dollars, then you'd subtract the amount he spent on pizza, which would give us how much he has left. So in summary, recall that we have to recall our operations with fractions. We recalled our order of operations. Remember, a variable is just a letter that represents an unknown number. It's still a number. It's a placeholder for a number. It's allowing us to either determine what it is or allows us to put a value in there deliberately. That's called a variable. An algebraic expression is a meaningful collection of numbers, variables, and operations. All right, I hope that really helps.